Students, we are going to start a new chapter called magnetism. See, in magnetism, we try to find magnetic forces. Like in previous chapter, we studied current, electricity, electrostatics. There we found out electrostatic force. Now, the difference between electrostatic force and a magnetic force is electrostatic force can be applied on a charge in rest or charge in motion, but here magnetic force is basically calculated on a moving charge. Magnetic force cannot be applied on a resting charge. So like in electricity chapter we talk about electric field. Here there is a magnetic field, it is denoted by B. Now magnetic field, like electric field, is a vector, it has a direction. So we will see in depth what is the direction, what are the rules and all that, in coming lectures. But right now you need to understand that there is something called magnetic field, because of which only a magnetic force will be developed. On what? On a moving charge. Moving charge means current in a conducting wire. So whenever you see a current, you should always think also in terms of what is, if any, magnetic force is acting on this particular moving charge. Now this magnetic force direction and the electric field direction are different. Okay, so magnetic field decides basically how do you get a magnetic field. You get a magnetic field because of a permanent magnet. A permanent magnet can be your bar magnet. A bar magnet has a north pole and a south pole. So when you keep two bar magnets in front of each other, you create a magnetic field between the two magnets. Now this magnetic field will experience a magnetic force if there is a moving charge inside the magnetic field. Okay, so depending upon the strength of the magnetic field, the magnetic force also will vary. If the field is weak, the magnetic field will be, if the magnetic field is weak, then the force also will be very weak. If the magnetic field is strong, the force also will be strong. So the general method is like in electric field. How do you decide that at a particular point a electric field exists? You put a test charge. Suppose in space I am inside a room, and at a particular point I want to know if there is any electric field. How do I do that? How do I come to know? I will put a unit charge, 1 coulomb charge over there, and if the charge is experiencing any electrostatic force, I will say that there is definitely some electric field over there. Similar concept we use in magnetism also. Now you can see here I am giving some notes. Magnetic forces act only on moving charges. If it is on rest, there is no magnetic field. Okay, you can make a note of all this. So the condition is that V must not be equal to 0. Magnetic force is denoted by Fm. So there must be some formula to calculate this. So magnetic force, there is a formula, and the formula is Fm is equal to Q into V cross B. It is a cross product, it is not a dot product. Remember, every cross product always has a direction. About direction we will see in coming classes. Here it is Q into V cross B. Q means charge, V means velocity, B means magnetic field. It has to be V cross B only, it cannot be B cross V. First remember that. Okay, and let us say if theta is the angle between the velocity vector and a magnetic field vector B, then we can expand this formula as QVB sin theta. Now this theta is the angle between V to B. Always measure from V to B and not from B to V. The direction will change. The direction will totally change if you measure the angle between B to V. So in which scenario there won't be any magnetic force? If B is equal to 0, that means if there is no magnetic field at all, there is no question of magnetic force. If there is no charge, suppose the magnetic field is there but inside there is no charge, no question of magnetic force. Suppose there is a charge but the charge is not moving, then also no question of magnetic force. And mathematically, if theta is equal to 0 or theta is equal to 180, there is no magnetic force, because sine 0 is equal to 0, sine 180 is equal to 0. Now what is the unit of B means? How to find the unit of B? F is equal to BQV. So if you rearrange, F is in newtons, Q is in coulombs, V is in meter per second, you finally get Newton second by coulomb meter. Now this is called Tesla. Tesla was the scientist. It is the SI unit. There is another unit called Gauss, Gauss. Gauss was another scientist. This is a CGS unit, and there is an interrelationship. 1 Gauss is equal to 10 power minus 4 Tesla. Okay. Now in many problems they will use this unit Gauss. Always remember this particular conversion. It is very, very important. Thank you. We will see in the coming lectures the remaining aspects. Thank you.